Okay, here's question number 2 from our 1D kinematics practice problems. Here we have a car undergoing constant acceleration. We are given how far it's gone and how long it took. We're also given its initial velocity. It started at rest. So let's write all of this information down. So what we're given is that it's traveled a distance of a quarter mile. And we're given the time it took, delta t, is 6.7 seconds. And we're given the initial speed, which was 0. We'll just keep it in meters per second. Now our question asks us for the final velocity, either in miles per hour or meters per second. So I'm going to do it in meters per second. Which means we have to convert our distance. So remember the conversion from miles to kilometers. We have a quarter mile. If we multiply by 1.609 kilometers, that's equivalent to 1 mile. And again, we have to then convert the kilometers to meters, and 1 kilometer is 1,000 meters. So we should get 402.25 meters. Okay, so there's our distance traveled, our time, and our sorry, that I wrote final velocity. This should be initial velocity. Okay, now this is going to be a two-step problem. I'm first going to find the acceleration. We're told that it's constant, and I can use the following equation. I know that our distance traveled is equal to the initial velocity times time plus 1/2 times our acceleration times delta t squared. We know our initial velocity is 0, so this term goes to 0. And we can solve for our acceleration, which is just 2 times delta x over delta t squared. So then we just plug in all the values that we have. It's 2 times 402.25 meters divided by 6.7 seconds squared. And the acceleration we get once you've plugged it into your calculator should be 17.92 meters per second squared. Okay, now that we have the acceleration, we can use our another equation we have for motion with constant acceleration, and that's the following, that v final squared is equal to v initial squared plus 2 times our acceleration times the distance traveled. So from here we can solve for the final velocity. Note that the initial velocity again is 0, so we need to compute the square root of 2 times the acceleration, which was 17.92 meters per second squared. And we're multiplying by the distance, which was 402.25 meters. And what we end up with is a final velocity of 120 meters per second. Okay, note the problem is given in 2 sig figs. That's due to the 6.7 seconds. So here we have 2 sig figs as well. We wrote down our units in meters per second, which we were asked for. So there is the answer.